Okay, so let's try one more of these power rule problems. I'm going to write out all the steps for this one, but you definitely can skip steps if you are inclined to do so. So when I get ready to take this derivative here, first of all, I see that I have a 6 out in front, so I'm just going to keep that 6 out in front. And then I'm going to take the derivative of x to the 5th. Well, to take the derivative of x to the 5th, that would be a 5 out in front, and you're going to decrease that 5 by 1, and that's what the power rule says to do. So for this particular piece right here, when I clean it up, that would give me a 30 out front and an x to the 4th. And that's how that piece would look. Okay, so let's move to the second one. When I move to the second term, I have a negative 5 halves out in front. So I'm just going to leave it alone. The next piece, I have to take the derivative of x squared. Well, to take the derivative of x squared, I would multiply by 2, bring that 2 down. So multiplying by 2 is the same thing as bringing that 2 down, and then I decrease the 2 by 1. 2 minus 1. So when I get ready to look at this term, that 2 is understood to be 2 over 1. So if I multiply that part out, I get 10 over 2, which would give me a minus 5x. You'll say, now what happened? A lot of people don't like the fractions. But if you had a 5 over 2 times 2, those 2's cancel out, and that's where the 5 is coming in. Okay, looking at the last one, sorry, not the last one, but looking at that x, the last x, you're understood to have a 1x there. So there's the 1 for the 1x. Now, remember this is an understood 1 right here, so I'm going to bring that 1 down, and I'm going to decrease the 1 by 1. So this particular piece would be 1x to the 0. Remember, x to the 0 is just 1, so this would just be a value of 1 right here. And then you say, well, what happens to the 5? Remember with the 5, let me fix that, sorry. Remember with the 5, the derivative of a constant is 0. So you could put a plus 0 on the back to represent that's where the 5 went, but the derivative of a constant is 0, so it just doesn't have a place in the derivative. So your final answer for this particular problem would look like this. Okay, so far in this section we've done the basic power rule. That was the main thing. But now we get a couple of applications in there. So for this problem, I ask you to find the equation of the tangent line to the graph of f of x equals x cubed minus 3x at the point 2, 2. Okay. To find the equation of any line, you use the point-slope formula. We went over the point-slope formula at the very beginning of the semester. It was in, I guess, Chapter 1. It's also in college algebra, so it is a concept that we expect you to know before you get to calculus. Your point-slope formula is y minus y1 equals m times x minus x1. You will have to know that formula for your test. Now, of course, with this particular problem, you have a point, that's your xy, and that's 2, 2. So you have that, but what you don't have is a slope. So the way that tangent lines work and the slope works is the slope is the derivative. So we're going to go over here to my function again. Slope is m, so slope is the same thing as the derivative. So for this particular problem, my derivative, I'm going to take the derivative of the function. So that would be a 3x. Okay, when I decrease the exponent by 1, 3 minus 1 would give me a 2. And the derivative of 3x would just be 3. So that's my derivative of that function. You'll say, well, how's the slope coming in? Well, to find the slope, we have to plug our x value into that expression. Okay, so here's your x value right here, 2. So my slope is 3x squared minus 3. I'm going to plug that 2 in because x is 2, so I'm going to plug 2 into the x position. So what I get for that is 3 times 4 minus 3. Okay, and I got 4 because that's 2 squared. 3 times 4 minus 3. So that would be 12 minus 3, which is 9. So for this particular problem, my slope is 9 and my point is 2, 2. I can plug those blue values into my point slope formula and I'll get my equation. Now we've already done this semester, so I'm going to go a little fast through it. So we're going to say this is x1, this is y1, and this is m. Y minus y1 equals a slope times x minus x1. So y minus 2 equals 9x minus 18. I always make you solve for y. So to get y by itself, I'm going to move this 2 over. Please watch your signs. And y equals 9x minus 16. And that's what we get. Okay, let's try one more of those. Find the equation of the tangent line to this graph. Okay, anytime I ask you to find the equation of the line, that's your point slope formula. Okay, I have a point already. The point is negative 1, 6. So that's going to be my x1 and that's going to be my y1. I do not have a slope. So to find the slope, I'm going to take the derivative. My derivative here would be bring down the 3, decrease by 1. 3 minus 1 gives me 2. Okay? Bring down the 2. So 2 times 2 gives me 4. Decrease by 1. The derivative of 5x is 5, and the derivative of 10 is 0. So that's my derivative. I need to know the derivative at this x value. So here's the x value. So plug in negative 1, and that's going to give me my slope. So that's 3 times negative 1 squared plus 4 times negative 1 plus 5. Well, negative 1 squared is 1. This would be a minus 4 here plus 5. 3 minus 4 plus 5 would give me 4. My slope is 4. So now that I have a point and now that I have a slope, I can plug these into my point slope formula. Y minus y equals my slope times x minus x. Now I need to clean up that double negative. Okay, so that's how it looks so far. I'm going to move the 6 over. And y equals negative 4x. Whoops. Okay, so I found the mistake. So right here, you'll see a mistake. So let's go back and fix it really fast. So I miscopied it and I put a little negative right there. So that was wrong. So let's go back and fix it. That way we don't have to start the whole video back over. So sorry. Math teachers make mistakes too. Alright, let's try this again. It should be correct to this point. So sorry about that. So we have our y minus 6. I'll go ahead and copy it. I want to clean up this double negative. So that's going to be x plus 1. I'm going to go ahead and distribute through. I'm going to move the 6 over, and y equals 4x plus 10. And that looks a lot better. And that's what we would get for that one.